Please open in your learning workbook to page 132. Let's solve a problem involving graphing a quadratic function. Graph f of x equals 1/3 parentheses x minus 6 close parentheses squared, including its axis of symmetry. State the vertex and equation of the axis of symmetry. Alright, well, I've written the steps for how we do this here on the right side of the board. Let's follow them together. First, find h and k and put them in a table. Alright, well, we know that h is the number being subtracted inside the parentheses, so h equals 6, and k is the number being added or subtracted outside the parentheses. There is no such number, so k equals 0. Alright, we're going to put that in the center row of an xy table. 1, 2, 3, 4, 5 rows, and we're going to put that right in the middle. This point is our vertex of our parabola. Now, to find the other x values that we're going to use, we need to find a and note its denominator. A in this problem is 1/3. And the denominator of 1/3 is 3. So we are going to use the number 3. We're going to add and subtract 3 from this x value, which for this problem happens to be 6, to find the other x values that we will use to graph our parabola. So 6 plus 3 is 9, plus 3 again is 12. Going the other way, 6 minus 3 is 3, and 3 minus 3 is 0. All right, so now we have our x values. We need to find our corresponding y values. We do that by plugging into our equation. So let's begin. F of x is the same as y. So we could write our equation as y equals 1/3 parentheses x minus 6 close parentheses squared. Now let's plug in each x value. Here we go. If x equals 0, then y equals 1/3 0 minus 6 squared, which is 1/3 times negative 6 squared. Remember to follow order of operations here. Exponents happen before multiplication. So that means we need to do this part before the multiplication by 1/3. So we get 1/3 times negative 6 squared, which is 36. Now 1/3 is a fraction, 36 is not, but we can write it as a fraction, 36 over 1. And then when we cancel, 36 divided by 3 is 12, so I could write that as 12 over 1. We get the final value, 12, because anything times 1 is itself, and anything divided by 1 is itself, so we get 12. Now, for comparison purposes, the next x value that I'd like to try is this x value, which is 12. And the reason why I'd like to do that one next is because I want you to see a comparison between these two calculations side by side. All right. If x equals 12, then y equals 1/3 times the difference 12 minus 6 squared. So y equals 1/3 times 6 squared. Y equals 1/3 times 36. Notice that these match. They are exactly the same. Why? Because the thing in the parentheses is the same number, just different sign. And when you square a negative, you get a positive, and where you square a positive, you also get a positive. So what that means is these two values are going to give me the same value of y. These two different x values will give me the same value for y. I'm going to get y equals 12. Now, will this always be true? The answer is yes, because a parabola has symmetry. Let's continue on, and we're going to see that it's also true when we use the values 3 and 9 for x. Here we go. All right, so if x equals 3, then y equals 1/3 parenthesis 3 minus 6 close parenthesis squared. Y equals 1/3 times negative 3 squared. Y equals 1/3 times 9. 9 is the same as 9 over 1. 9 divided by 3 is 3, which can be written as 3 over 1. 3 times 1 is itself, 3 divided by 1 is itself, so I get y equals 3. All right, now we'll try 9. If x equals 9, then y equals 1/3 parenthesis 9 minus 6 close parenthesis squared, which is 1/3 times 3 squared, which is 1/3 times 9. Notice, same thing. So, same answer, 3. Parabolas have symmetry. So if you're doing your work correctly, you should find that these two values match each other and these two values match each other. If they don't, then you've made a mistake and you should go back and try to fix your mistake. All right, so now that we have all of our ordered pairs, we're ready to create the graph of our parabola. Here we go. We notice that all of our values here in the table contain no negatives, which means my entire graph can be drawn using just quadrant 1. The biggest number that I see is 12, so we need to go all the way out to 12 in both the x and the y. And we plot our points. All right, so first we have 0, 12. That would be here, a y-intercept. Next is 3, 3. That would be here. Next is 6, 0, which would be here, an x-intercept. And we note that this is our vertex. I'll put V for vertex. Next is 9, 3, which would be here. And last is 12, 12, which would be here. Now we know that this parabola opens up because A is positive, and this is the vertex, which means that must be at the bottom of the U shape. So from the vertex, we go up through the points that we've already graphed. From the vertex, we go up through the points we have already graphed. Okay, so there's our graph. Now we have to graph the axis of symmetry. The axis of symmetry is the vertical dashed line through the vertex. And the equation of the axis of symmetry is x equals h. Well, for this problem, h is 6. So the equation of the axis of symmetry is x equals 6. All right, so I think we've done everything that we've needed to do here. We created our graph, we graphed the axis of symmetry, we stated the vertex, and we graphed and we provided the equation for the axis of symmetry.